Alright guys, in this video we're actually going to talk about Brazil for Rhino and some of the material options involved. So this file is called texture mapping render file, and in the sort of course materials it can be found here. Brazil texture mapping examples. This is a zip file that contains a couple of things that you see here, including the Rhino file that I have open here. Now this Rhino file should be more or less already set up. If I render it, this is roughly what it should look like, although your settings may vary, in particular in regards to the shadows and the sun direction, etc. So you might have to check your own Rhino settings if it didn't carry over. But this is what it looks like overall at first, and just to kind of give you an idea. So this is a sort of grid matrix of different objects, and down here in this row, these are basically different material mapping options. Now it'll make sense in a little bit as I kind of select one of these guys. If you look at the properties panel, the object properties for any of these objects, when you select it or have it highlighted, let's say for this big first guy here, when you have it highlighted, you'll find basically by default it should look like this. The object, it'll tell you what kind of object it is, closed surface, etc., etc. So this donut, what layer it is, etc., etc. But if you click over to, for example, material, it will tell you what material it has applied to it. The next one that we're really concerned with at this moment is this one, texture mapping. So when you have the texture mapping button active, it will tell you what sort of texture mapping it has. Now, by default, when you create, one of these objects, it probably doesn't have any texture mapping applied. So, give you an idea, I'm just going to really quickly make a new cube right next to it to show you what a material or an object without any sort of mapping pre-applied to would look like. So it'd be blank basically. And this blank sort of version is sort of fine for most materials or most colors. Basically, any type of material that doesn't really have a scale. And so for example, if you're importing from SketchUp, sometimes, in most cases, the sort of material colors you've applied to SketchUp will actually carry over to the Rhino file. Now, if you're using or you want to use Brazil Render native materials, then you have to come here, Brazil Render Shortcuts Material Editor, which will bring up this panel. And I'm going to make this, you can sort of resize these a little bit. And you'll see the material editor. Now, there's a couple materials there by default, and the tune material we showed you how to make last time. A concrete material that I think this one I probably grabbed or downloaded. And we'll show you actually really quickly how to make a simple material. So if you click on this plus sign, it'll bring up this dialog box. And in this case, you probably just want to find this guy, the Brazil Advanced Material. Okay, and it'll come in, you'll see a preview of the material. And if you want to see it larger, you can sort of drag it bigger. So these sort of are all somewhat resizable. So with it selected, then you can actually come down. And for most purposes, the main thing you change is the diffuse color. So it's gray right now. So I guess if I want to change it to something else, then you click on it, and maybe let's make it dark green. And you'll see the render sort of window will actually update to kind of show you this is a preview of what the material is likely to look like. So you'll see that there's a lot of other settings here, but if you're just making a diffuse material, this is probably the main thing you change. You'll also see actually under the Brazil default you can change the opacity if you want, so that kind of opens the thing for having transparent materials. And down here you can change the glossiness, refraction, etc. And these are a lot of extra settings that generally you probably won't mess with too much unless you're really sure about what you want to do. But to kind of look at what happens is that you can actually just like select this object, right? Right click here and assign to selection, or the way it kind of works, you can just sort of drag and drop like I am now. So click, drag and drop and let go. Now I am in shaded view right now, so you can't actually see it, but if you change to render view, then it would show up. So rendered view will basically kind of have you a preview of what sort of materials you have selected, and can render it really quickly just to see what it looks like. Now, one thing you have to keep in mind is that the way materials show or look is also very highly dependent on your scene lighting, right? And so all of these things sort of add together to contribute to the overall. In most cases, as far as rendering is concerned, you want to basically use a sort of a generic white clay model to sort of develop your lighting solution first before you actually start tweaking materials. Because for example, if I just sort of change my environmental lighting and make it a little darker, then that will completely change the sort of how materials show. So you probably don't want to, mess that up too much. So the best idea is actually to lock down the lighting solution before you try to actually develop any materials. Okay. Now, the sort of scaling or the sort of mapping that we were talking about earlier here really doesn't matter for a sort of uniform color, applied material like this. It doesn't matter what sort of scale it is, it's a uniform color, right? Now, I think the issue or the problem really comes when you have a material like this, which is a concrete material. Now, this concrete material obviously has sort of surface subdivisions or tiles or whatever you want to call it, and the way that these are mapped to geometry makes a difference in how it reads, and therefore the UVW sort of mapping system. Now, this is actually a system that's pretty much consistent or true probably of all 3D rendering programs. Okay, so in the sort of texture mapping panel, you'll find some examples, like if and these are just different geometries to show you how things will map. Now, in this case, for example, in the object we created earlier, if I wanted to add a texture mapping, basically I would highlight it like this, select it like this, and come and say, apply surface mapping. And you'll see on the upper left, mapping channel for surface mapping 1. You can just say enter and confirm it. And you'll see that now it gets populated with a surface mapping type, and you will get some options down here. Now, surface mapping is sort of like the most generic, simple mapping version. And as you can see here, with the sort of rendered mode, display mode activated, that when I have the sort of concrete material applied, surface mapping will basically kind of give its best guess as to how you want mapping to be applied to the object. So in the sort of case of the torus or the donut, it will try to wrap it this way. In the case of the cube, you'll see that it basically try to fit the mapping tiles to the surface size. Now, one of the side effects of this is that basically if this is the texture size, it will basically try to map it to the geometry faces, regardless of the geometry size. And so in this case, for example, you'll see that if I non-uniform scale it, so this is what happens, right? These get sort of more square, but then these get elongated because it's trying to fit basically the same sort of 8 tiles to the surfaces, regardless of the size of the surfaces or the sort of proportion of the surfaces. And that's the big problem. So you'll see in some cases like the sphere kind of works. In the cylinder, okay, you'll see the cylinders, it's trying to wrap it horizontally there, and here it's sort of, you know, projecting it as a plane, etc., so on and so forth, right? So the surface mapping type is, sometimes it will work depending on your geometry, sometimes it's just like, you know, it does this. Okay, so the next type you'll see is the planar, and it's basically the same thing. If you have a dummy object on, if you have a dummy object on the side, you can just select it. And here I will delete the mapping first, select it, and say the next one, which is planar mapping, and say apply. And remember always to kind of look up here, because sometimes these commands will basically ask you to input something. And in this case, I'll just do bounding box, which sort of grabs your object's bounding box boundaries, and you can say world UV, and basically this you can just enter, like keep on entering to finish it. Okay, and so that gets applied. There's this planar mapping. So there is a way actually, and you'll see these sort of numbers or these sizes that tell you the position of the mapping and the size of the mapping. So there's an option here called show mapping. So basically what this does is that it gives you a sort of dotted line representation of what the mapping looks like. And this is the mapping size basically. So if I change the location of this, for example, then you'll see these XYZ positions change. These numbers will change. And if I change the size, so these are the dimensions basically of the this sort of square, 8.113 and 9.644. And I can, in this case, for example, try to make them consistent. So like here, I can lock the XYZ so they're the same dimensions. Or I can input one and, input 1, 10, 10, 10, for example, and lock it, right? And that basically makes this sort of mapping gizmo 10 by 10 by 10, and that's the mapping size. Well, in this example, because this is a uniform sort of color, it's probably not as evident, but you'll see in this in particular the donut. And let's show the mapping here. You'll see basically this is a planar projection mapping where it's sort of grabbing the sort of outside square boundaries of the torus and basically taking the mapping and projecting it through the donut as if it's cutting through it. And so it'll have these sort of elongated sides, and it's as if you were sort of looking at it from the top and running it through the cheese grater. The nice thing about the newer versions of Rhino 5 is that when you change the mapping, it will update. So in this case, for example, if I move it, you'll see the surface mapping updates as you kind of adjust it. It might be a little fast or slow to kind of update depending on the size of your map, but it gives you a pretty good visualization. And you'll see if I rotate it, right, then it updates as well. And or especially this shows more in this direction. So now it's actually sort of slicing or projecting diagonally through the donut, right? So this is actually the representation, pretty good representation, and it basically kind of helps you position things. The problem with planar mapping is when it comes to these types of three-dimensional objects, because the mapping is sort of perfect on top, but on the sides it's like sort of strata. So on the top and bottom it works, but on the sides you'll get this. And the same for this one. It'll work as if you're looking at correctly from top, but from the sides it gets these sort of elongated sides. So, you know, the reason I put all these sort of different objects here is just to give an idea of how the planar mapping will behave. All these different types of mappings will behave when it runs into these different shapes. All right, so what you want to do, and actually this one, the box mapping, is probably one of the more versatile ones, or the ones that you will probably be using the most. Right now, the box mapping, let's see if we try to apply to this guy. So I'm gonna delete the planar, select it, and it's the next one down, apply box mapping. And as the same here, bounding box, so I'll just enter capped yes, enter, and let's take a look. So in this case, the box mapping usually will just sort of snap to your bounding box size, but that might not be desirable because let's say this geometry is actually not, you know, a perfect cube, right? I just sort of winged it, so its dimensions are kind of weird. So you'll see here the dimensions are non-uniform. So in that case, I can either do the XYZ I did before, or I can do 1, 1, 1, which actually makes it a 1 by 1 by 1 cube. Right? You can lock it. So once I lock it and I change one of the numbers, 10 by 10 by 10, then everything sort of changes with it. Right? So that's kind of a quick and easy way to do that. To lock the sort of XYZ ratio. Right? Now, the characteristic of the box mapping is it projects as if it was a cube. So it's very well suited to these sort of situations where you know, sort of more orthogonal object. Maybe not so much for these sometimes, but it just depends. Especially not for a sphere, as you'll see the sort of seam where, you know, the box projections kind of intersect. So you'll see these, for example, will have a sort of pretty awkward relationship, but basically these faces are projecting and they're sort of running into each other on the sphere. Now the same thing with this, though, if you show the mapping. So this mapping in particular is 15 by 15 by 15, right? And right now it seems like it's aligned pretty well. But what you can do is actually, for example, use the move command, M, spacebar in my case, and these are things that you can actually snap to. So these mapping gizmos, you can actually use the OSnap to snap to and actually move them like that. So in this case, for example, I just wanted that sort of lower left corner to match perfectly with the lower left corner of my geometry, so I can just move it like that. And that sometimes basically just kind of helps you align. For example, if you had certain tiles and needed to be at certain directions or locations, then you can do that. Or in this case, since the tiles are running vertically, I want to rotate it, let's say, so it's the other direction, then I can do that. Right? And you'll see this is because you see a visualization of it, it's actually really easy to manipulate. And so, okay, when you rotate it, then this is what happens to your mapping, right? So it gets rotated. And so this is basically the sort of virtual representation and how it manifests on the surface of your geometry. Then you can obviously hide it like that, right? So take a look at these. There are some that are a little bit more well suited. These are the spherical, cylindrical, capped cylinder, and just so you can kind of see the letters a little better. But as you kind of look closely, some of these are very, very situational. You know, the cylindrical, etc., spherical just kind of works good for spheres and nothing else. But in some ways the torus kind of, right? But you can mess around with these. All of these will have basically their own parameters, their sizes. So the thing to kind of do is really just to show the mapping, look at how they are sitting in relationship to your object or to your geometry, move them around, see what changes, mess with the size or the position, and this way it's actually kind of easy to see what sort of changes you're affecting. In this case, as I'm sort of moving it off axis, then the projection changes drastically, right? It'll bunch up on one side, open up on the other, etc., right? But these are the mapping options that are available to you. This is more or less in the sequence, so surface, planar, box, spherical, cylindrical, and that's it. And you can delete mapping this way, so that sort of reverts it back. Show mapping, hide mapping, these you don't want to mess with too much. Some mappings have different types of projections, closest point, but you can mess around with those a little bit. But to be honest, for the most part, these three, the surface, the planar, and the box, are probably the three that you will use the most, especially the box, because the box is just easier to kind of work with in general. Remember these XYZ size things that you can play with. Don't worry too much about the offsets or the repeats for now. These basically kind of change the texture sizes, but there's no reason you shouldn't just use the XYZ size for the most part. And that's it. Now, I have provided in the folder basically, and I've changed the settings on this render. As you saw before, it's a pretty small one, but this is a pretty big rendering. I think it's like 3600 wide, 24 high. A pretty big rendering that kind of shows you in more detail what the renderings come out as, and where you can see, okay, this is what happens in these sort of different types. So yeah, this is sort of reference for you to look at as you experiment. All right, that's it for this video, and we'll see you in the next one.